sine graph and the cos graph are what we call sinusoidal functions. The tan graph is not a sinusoidal function, but it is a periodic function, which means that it repeats itself. Okay? Now, the difference between sine and cos, the major difference between sine and cos and tangent is the period. The period for a tangent function is pi. All right? So that means then that it repeats itself every pi degrees or radians, sorry, pi radians. Okay, so let's have a look at this. The second thing that we need to remember is tangent is found by taking sine over cos. All right, so let's start at 0 degrees radians. Let's start right here. Okay, 0 over 1. What is it? 0. Now, in the sine and cos graphs, we take 90, 180, 270, pi, 3 pi over 2, so 2 pi, okay? In the tangent graph, we actually go to the pi over 4s, and we use the pi over 4s, because you're going to see that they start to repeat themselves. All right, so at pi over 4, root 2 over 2 over root 2 over 2 is what? 1. Okay, so I put 1 right here. Now, here's another significant difference between sine and cos. Looking at pi over 2 now. Okay, and I should write these in. So let's do this. 0, pi over 4, pi over 2, 3 pi over 4, 1 pi. Okay, at pi over 2, what does the sine over cos give you?
1 over 0.
1 over 0. What do we refer 1 over 0 to? Is it 0? No? What do we say 1 over 0 is?
Undefined.
Yes, very good, Rania. Undefined. Okay? Now, anytime that we have seen an undefined value on a graph, we draw in an asymptote. So I now take a line, an invisible line, well, not invisible, but an imaginary line, and I draw it straight up and down. The tangent graph then approaches that line but never crosses it, so it goes up like this into that position. Now let's look at 3 pi over 4. What's the value of 3 pi over 4 for tan? -1. Okay, so this is 1, this is -1, right here. What's the value of pi? No.
0.
Yeah. 0 over -1, right? So, and remember, I said it's a periodic function, so look what happens. Okay, if I go down here to 3 pi over 4, or sorry, 5 pi over 4, 5 pi over 4 down there, what's the value of the sine graph now, or the tan graph now? 1. So now it goes to right here. And if I go to 3 pi over 2, what's the value of the tan graph? Undefined. There's your tan graph. Now, we don't work with, I don't think we work with A's or B's. We might only work with C's and D's. Just have a quick look here. No. Yeah, graphing wise, we actually do no transformations of it. Okay, now, everybody's okay with this? So again, it comes from my unit circle. The tan value here is 0, tan is 1, tan is undefined, tan is -1, tan is 0 again, tan is 1, tan is undefined. Okay, now to complete one complete period length, I could go from 0 to pi. All right, so now here's the questions that you need to be able to answer that are a little more complicated. I'll keep that small over here. All right, first things first. The domain of this graph. What is the domain for this graph?
X doesn't equal pi over 2 plus k pi.
Yeah, awesome. And
And an element of reals.
yeah, wicked. Okay, that's awesome. X such that. All right, X is an element of all reals. We get that part. However, X cannot equal is exactly correct. Where do all my asymptotes occur? 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, negative pi over 2, negative 3 pi over 2. So all my pi over 2 values, but not all of them, all the odd ones. So there's two ways to write this. You said it great. Plus k pi, where k is an integer. So all pi over 2's, add pi. Let's look at the unit circle to make more sense of that. Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2. So every pi value, you have an undefined. That's the easiest way to write that. There is a secondary way to write it, and that is X such that X an element of all reals. I am talking about only the odd values of pi over 2, right? Because 2 pi over 2 is pi, 4 pi over 2 is 2 pi. Those aren't undefined. So I want to write odd then. So how do I write odd? Well, 2k plus 1 pi over 2, where k is an integer. I like this a lot better, but this does say the same thing. All right? If I multiply any value by 2, it gives me an even number. If I add 1 to it, that means it's always odd. So to show an odd value of pi over 2, I put 2k plus 1 in there. But again, not necessary. If you understand that it's all the pi over 2's, add pi, easier. Okay? What is the range for this function? Yeah. Y is an element of all reals. It goes up and down forever. Okay? Now the last thing that we need to do is work the x-intercepts. Where do all the x-intercepts occur?
That the values of pi.
Yeah. All pi values. So your x-intercepts equal k pi, where k is an integer. All right. So the obvious difference is your period for tangent is pi. So every 180 degrees it repeats. You have undefined values when your cos value is 0. Okay. Our domain has breaks in it where part of the graph can't equal. Okay. And our range for this one is not -1 to 1 like sine or cos. It is an element of all reals. Okay. That covers example 1. Let's have a look at example 2. get through this quickly today, and then we'll finish up yesterday's and today's. All right. So an airplane is flying at a constant altitude of 9,700 meters in a straight line directly above radar station. How does the horizontal distance between the plane and the radar station change as the plane crosses overhead? Okay. So looking at this triangle right now, and not thinking about anything, let's say my angle right here is theta. And I know this is 9,700 meters. If I know what theta is, so let's assume that I know what theta is. How do I find x here? If I know what theta is, how would you find x? Okay, we could do it that way for sure. Yeah, absolutely. But let's say, okay, let me do it this way. Let's put a value in right now, because sometimes it's hard to understand. So let's just hypothetically say that's 30 degrees. Tell me how you would find x with just that information right there. How would you find x? Use tan? Okay, so I would have tan 30 degrees is equal to the ratio, which is 9,700. Perfect. Okay, so therefore x would then equal what? Okay, so now I'm going to substitute in theta because I don't know the angle times 9,700. Okay, so now what the question is stating is it says, how does the horizontal distance between the plane and the radar station change as the plane crosses overhead? Well, you label the complementary angle to the angle of elevation as theta, and then label the horizontal distance as h. We labeled it as x. So tan theta would be equal to x over, or h over 9,700. H is then equal to tan theta times 9,700. So as theta approaches 0, what happens to the horizontal distance? So as my angle gets closer to 0, what's happening to the distance? Gets smaller, right? 100%. So as tan theta gets closer and closer to 0, it gets smaller. And then it eventually is overhead, and then it carries on, and it repeats itself. So if you're looking at the graph of this guy, so let's say it starts over here, and it's flying in this direction, okay? You've got it as negative pi over 2, whatever. So the graph would look like this. In which this is negative 9,700 right here, and this is 9,700 right here. So instead of 1, you'd have 9,700. And then it would carry on at that point. So as your tan gets larger, you would keep multiplying it by 9,700. So instead of, as we get going, as it keeps going away from here, all right, it's going up. This is going to carry on. Okay, so as the angle gets larger, then obviously the horizontal distance is going to get much larger. But if you have an angle of 0, your horizontal distance is still 0. But as it increases, it gets greater than 9,700. All right. So at what value for angle Are we at 9,700? What angle creates 9,700 as your horizontal distance? And why? So this is the above and beyond question. Can you answer this question? Do you understand what it's saying? What does the angle theta have to be in order for you to have 9,700 as your horizontal distance?
Is it 180 degrees?
Pi?
Oh, then pi.
Possibly.
Yeah.
Okay. You think pi? Anybody else? What does the ratio of tan theta have to be in order for h to equal 9,700? Look at the board. What does tan theta have to be as a ratio in order for h or x to equal 9,700? What does tan theta have to be?
1.
1. 1 times 9,700, correct? Yeah? So where or what angle does theta have to be in order for tan theta to equal 1?
Pi over 4.
Yes. So the answer to my question is this. That's above and beyond. At pi over 4, the tan of pi over 4 is equal to 1. Root 2 over 2 over root 2 over 2. 1 times 9,700 gives you 9,700. That's where the angle has to be in order for the height or the horizontal distance to be 9,700 for that question. Okay? And then as you get further away, so what's the next one? Pi over 2 over here. What was the ratio of pi over 2 for tan theta?
0.
Is it 0?
Yeah.
Undefined, right? So then the graph has to reset itself. So we're basically talking between pi over 4 and pi over 2 is where the horizontal distance will increase. But once it hits pi over 2, it becomes undefined again, meaning it's straight over top. All right? Okay, so we'll deal with that a little bit. We'll do a little more work on it. I don't think you're going to have too many issues with it. There is one more question very similar to it on number 6. Question 7. You can try question 7, but in all the years I've done this class, it's a rarity that we have come up with the correct solution for it. Question 7 is a little bit harder to understand, but question 6 is a very similar question to this, so you can do it. Have a look at yesterday's. Any issues with the sine or cos graphs from yesterday? Identifying them, drawing them. Any issues?
Do you have to have, like, for the x value specific, like ones, or can we just sketch it and then fill in?
Okay, so if you're doing the method where I draw the line like this, then Martin, then this guy has to be your C value. Okay? And then this guy has to be your C plus your period. So those are specific. If I'm doing the chart way, then I'm going to be very specific. I want 0, pi over 2, pi, 3 pi over 2, and 2 pi as my x values. Okay? But if you're doing it this way, you only need C, and then you can put in your axes anywhere, and then you can label it however you want down here. It's just that from here to here, and these 5 have to be labeled correctly. And then whatever you put down here doesn't matter. It has to just line up with it, okay? All right? How many of you did the chart yesterday? The chart way of doing it? Just, did you? Okay. Ashlyn, did you do the other way with the line or the chart? You did both ways? Rania? Same? Autumn? Did both? Yeah, okay. Hannah, you're catching up? Okay. All right, so which way do we like? Which way do you find quicker? Yeah. Especially if the axis is labeled for you, it's easier to sketch it with doing this method here, for sure. But I like showing you the other way because you've been doing it all the way through. It keeps you consistent. No other questions from yesterday's work? Okay. Let's finish to the end of 5.3 today, and that's tangent function.